Welcome back everyone. Today just a super quick little video just building on my last one on how a semiconductor works. Today we're going to take a look at a transistor and just look at how it actually works. So let's get started. So let's take a look at this representation of a transistor, and before we start let's just have a look at the circuit diagram. Emitter, base, collector, and this is an NPN transistor we're looking at the moment, as you'll see by the material. So here we have the emitter, the base, and the collector. So let's take a look at what happens when we put a battery across the device. So we'll put a voltage source across emitter collector. Now let's take a look at the actual device in detail. We've got an NP junction here, which is just the same as a normal diode that we've looked at before. And please, if you haven't watched my previous video on semiconductors, go and have a look at that because it explains it in detail. But we've got a depletion region created here, just like a normal PN junction, and we've also got another PN junction here with base collector, and we've got another depletion zone created here. Now with this battery connected this way, effectively we've got two diodes back to back, so one will be reverse biased and no current will flow, so nothing happening there. Okay, let's now reverse that so that we now have positive here and negative here. So again, the same thing, we've effectively still got one reverse junction, so no current will flow. Okay, so now let's take a look at what happens if we put another voltage source between the emitter and the base. Now we've still got this depletion zone here, however we've now got a positive voltage on this p-type junction, and we already know that once you get to about 0.6 or 0.7 of a volt, the depletion zone will be overcome and we'll start to get current flow. So we will start to get current flow between the emitter and the base once we get over 0.6 volts. Now that's all good and well, but this N-type junction for the emitter is very heavily doped, so there's a huge excess of free electrons. This base is lightly doped P material, so it's only got very few holes here. So when we forward bias this junction, the electrons start to move in here at a great rate. Now the base junction is very thin and it's only lightly doped with very few holes, so it can only take a small amount of that electron flow out here as base current. But what happens is we've actually got a higher positive voltage here on the collector, and when these electrons get into the base region, they see this higher positive voltage and get attracted straight through to the collector. So for a very small amount of emitter base current flow, we end up with very large electron flow from emitter straight through the base to the collector. And this is basically how a transistor works. We get current amplification with a small base current producing a large emitter collector current flow, and the actual ratio of those currents is the beta of the transistor, or the gain of the transistor. So that's how a bipolar transistor works. So one other thing that we should mention is if we turn this emitter base junction on quite hard so that the transistor is fully on, then the current flow through emitter collector will saturate as well, and effectively we've generated a switch. So this is the transistor being used as a switch. We either turn it off fully or we turn it on quite hard so that the device saturates, and that's the basis of using the transistor in a digital circuit. Two states, on or off. So I'm hoping that helps you understand how a transistor works. Please like the video if you like what I'm doing, and also please click the subscribe, and don't forget to click the chime so that you'll see when I release new stuff. Okay, cheers.